Hello students, today we will do a question on magnetic field, basically magnetic force on a moving charge particle, and this particular question can be regarded as a difficult question. Yes, it is a difficult question. Let us see how many of you can do it. The question goes like this. The question says a particle having mass small m and charge q is projected from the origin with velocity v naught I cap. There is a particle having mass m and charge q. It is projected from origin in positive x direction with speed v naught in a non-uniform magnetic field. The magnetic field is not uniform. It is minus b naught x k cap. So, the magnetic field is in negative z direction, that is first thing, and the second thing is the strength of magnetic field goes on increasing as the x coordinate goes on increasing. So, if I take this as x axis, this as y axis, then the particle has been thrown this way, that is one thing. Magnetic field is in negative z direction, so it is inwards, but the point is the magnetic field goes on increasing as you move along the x axis. On this particular line or in this particular plane, magnetic field has got one value. If x is fixed, magnetic field is fixed. But when you move from here to here on this particular line, the value of magnetic field has changed because x coordinate has changed. So, the magnetic field strength is increasing as you move along the x axis. V naught, B naught are positive constants of proper dimensions. Okay, done. Find the maximum positive x coordinate of the particle during the motion. So, if I project a particle from here in this direction, then what will be maximum x coordinate of the particle? That is the question. I am getting out of this screen. You can capture the question and give it a try. Give it good 5-10 minutes. The mathematics required is a bit tricky and you need to think about it properly. Here goes my solution. The first thing that we need to notice is that the particle will move in xy plane only, right? Because the magnetic field is perpendicular to plane of this diagram, it is in z direction, and the velocity is given in xy plane only, it is along the x axis. So, if the magnetic force is perpendicular to plane of the board and velocity is in xy plane, force applied by the magnetic force, the magnetic field on the particle is also in xy plane. Magnetic force is always perpendicular to magnetic field. So, the magnetic field is like this or like this. In that case, force acting on the particle remains in this plane only. So, the velocity of particle is in this plane and force acting on it is also in this plane. So, obviously, the particle is going to stay in xy plane. So, particle is not going to have any component of motion in z direction, it will stay in xy plane. That is one vital thing that we should take note of. Another fact is its speed will never change as magnetic force is always perpendicular to the instantaneous velocity. I hope all of you know this, that if a charged particle is moving under influence of a magnetic force, then its speed never changes. Magnetic force never performs any work on the particle. Magnetic force is always perpendicular to velocity of the particle. So, its speed will remain v naught, though the direction of velocity will keep on changing, but the magnitude of velocity, that is the speed, it is not going to change. So, particle is moving in xy plane, particle will have a fixed speed, but the particle will not move in a circle as the magnetic field is not of constant magnitude. The speed is changing, is it? No, speed is not changing. Magnetic force is changing, yes, it is changing, because magnetic field strength is changing as the particle moves in the x direction. The strength of magnetic field is changing. So, magnetic force is changing, speed is not changing, but the force is changing. So, particle cannot move in a circle of fixed radius. For moving in a circle of fixed radius, if speed is not changing, then the required centripetal force is always mv square by r. It should have a constant magnitude. But here the magnitude of force is changing because b is changing. So, obviously, particle cannot move in a fixed circle. The path is not circular. That is the another thing, another key thing that we should notice here. And then at the instant x coordinate of the particle is maximum, its x component of velocity will be 0 and y component of velocity will have magnitude v naught. Very good. जिस वक्त पार्टिकल का x कोऑर्डिनेट मैक्सिमम होगा, आपने x डायरेक्शन में पार्टिकल को फेंक दिया, वो कुछ ऐसे पाथ के ऊपर चल रहा है, तो जिस समय उसका x कोऑर्डिनेट मैक्सिमम हुआ मींस x डायरेक्शन में उसने आगे बढ़ना बंद कर दिया, x डायरेक्शन में उसकी वेलोसिटी 0 हो गई फॉर ए मोमेंट, उस वक्त जिस समय x डायरेक्शन में उसकी वेलोसिटी 0 हो गई, उसकी पूरी वेलोसिटी y डायरेक्शन में होगी v नॉट. क्यों? क्योंकि अभी अभी हम बार बार कह रहे हैं कि भाई वेलोसिटी का मैग्नीट्यूड तो नहीं बदलेगा, पूरी वेलोसिटी तो उसकी v नॉट ही रहेगी. अब x डायरेक्शन में उसने बढ़ना बंद कर दिया, vx 0 हो गया, तो vy की वैल्यू v नॉट हो गई. तो पार्टिकल मैक्सिमम x कोऑर्डिनेट पे होगा जब vy की वैल्यू v नॉट होगी. ऐसा एक प्रॉपर सा डायग्राम मैंने यहाँ पे बना दिया है. This is point O from where the particle has been projected. It has been projected with some speed v naught. Let us say this is the path on which it is moving. At point Q, its velocity becomes parallel to y direction. It is v naught, and this is the maximum x coordinate. Because till now particle was having some velocity in x direction, so it was moving in x direction, advancing in x direction. But right now vx has become 0, so it has stopped moving in x direction, which means the entire velocity is in y direction. Okay. Now consider some intermediate point, right? The particle is somewhere at p and its speed is v naught, velocity is tangential to path, magnitude of velocity is v naught, and let us say coordinates of the particle is x comma y. At this particular instant, the magnetic force acting on the particle is somewhat like this, perpendicular to velocity, of course. B is inward, so v cross b, this is the direction of force perpendicular to velocity, right? So P is an I'm so sorry, just a moment, just a moment. Yes, so P is an intermediate point having coordinates x, y. The magnetic force on the particle at P will be given by, I have written it in Cartesian coordinate system. So the magnetic force can be written like this: Q, velocity. Right now velocity is like this. Let me write it in components: Vx I cap plus Vy j cap. So let us say velocity at this instant has two components, Vx and Vy. So velocity is Vx I plus Vy j, cross product Q V cross B, and the magnetic field is minus B naught x k cap. Remember, magnetic field is not constant, it is changing with x coordinate. So if the coordinate of the particle is x, this is the strength of magnetic field. So if you do the necessary cross product, I think all of you can do it. You have to do it like this: I cross k, then j cross k, you will get two terms. If you do the necessary cross product, this is what you get. Okay, what does it mean actually? When the particle is at this point and it is having this velocity, the force acting on the particle has got two components. This is the component of force in y direction and this is the component of force in x direction. So component of force in x direction can be written as mass of the particle into component of acceleration in x direction. This is what I have done. Mass times ax, ax is dvx by dt. So mass of the particle into rate of change of x component of velocity. Mass into x component of acceleration will be equal to x component of force, right? Similarly, mass into y component of acceleration dvy by dt, this will be equal to y component of force. This is equal to y component of force. I hope you are getting me till now. I have done nothing. Force is q v cross b. I have assumed that at any point velocity is vx I cap plus vy j cap. That's all. So just do the cross product. You get force as this much I cap and this much j cap. So obviously mass times x component of acceleration is equal to x component of force, and similarly mass times y component of acceleration is equal to y component of force. This is what I have written here, and we have to find, remember, we have to find x coordinate of the particle at the instant Vy becomes equal to V naught. The moment Vy becomes equal to V naught, at that instant Vx is 0. So when Vy becomes equal to V naught, what is the value of x? That is what we wish to find. And this second equation that I have written here, it involves two quantities which do interest us. It involves Vy and it involves x, and we are trying to have a sort of relationship between Vy and x. When Vy becomes V naught, what is the value of x, right? That is what we are trying to find out. So, this particular equation involves Vy and x. So, let us try to play with this particular equation. What I am going to do is, but I do not want time in my equation, right? So, I am going to use chain rule of differentiation, and I will write it as dvy by dx into dx by dt. What am I saying? I will write it as dvy by dx into dx upon dt. If you do that, then you can see a miracle happening actually. Mass times, in fact, I have transferred mass on this side. So, dvy by dt has been written as dvy by dx into dx by dt, right? Now, there is a miracle, dx by dt is nothing but vx. So, this vx and dx by dt cancels out, and now you are left with a relationship which only has Vy and x, and that is what you wanted. So, looking at this equation carefully and doing this manipulation is essential to solve this problem. I repeat, look at this carefully. Dvy by dt is dvy by dx into dx by dt. Dx by dt is vx, so dx and vx, dx by dt and vx cancels out, and therefore, this is what you get. I have written dx by dt as vx, and then I have cancelled out vx in the next step. So, this is dvy by dx is q b naught mx. Now, you separate the variables and integrate. Just move dx on this side and do the integration. If you do the integration, be careful about your limits. When x is 0, y component of velocity is 0. Particle was initially projected from origin and it was given a velocity in x direction only. There was no y component of velocity originally. So, when particle is at x naught, Vy becomes V naught. This is the x naught that we are willing to find. This is the x coordinate x naught when Vy has become V naught. This is what we are trying to find. So, we will integrate it like this, from x changing from 0 to x naught, Vy changing from 0 to V naught, and that is all. You just do the necessary simplification and you get the value of x naught. So, this is the maximum x coordinate that the particle is going to attain. I hope the solution is neat and clear and you have understood